So for the Buoyant Force Lab, we're going to use Pasco Capstone. Okay. So I'm going to do the hardware setup. The two sensors we're using are the rotary motion sensor and the force sensor. Okay, let's calibrate our sensors. For this one, I want to do 1,440 counts per revolution. That looks good. And for the force sensor, that's fine as it is. Okay, and then I'm going to calibrate the force sensor. Before I continue on with that, let me check something. Okay, I'm going to set the force sensor to 10 Hertz instead of 20 Hertz. All right, for the calibration, I'm going to do the two standard points. On the first one, I'm going to set the force sensor to 0. I'm going to now unhook the mass, a cylinder, from the force sensor. Okay, set that to the standard value. For this one, I'm going to put the mass, I'm going to load the force sensor with the mass. And is 1.06 newtons for 108 grams. Okay. I just loaded the force sensor with the cylinder. Okay, set that to current value, and then I'm going to press finish. Okay, the next thing we're going to do is set up an equation to relate how much the cylinder is submerged in the water. So the rotary motion sensor keeps track of how much we're lowering the cylinder into the water, but the amount that the cylinder is lowered doesn't correspond directly to how much it's submerged, because as I lower the cylinder into the water is going to rise, and the amount that the cylinder is going to be submerged will differ from the amount that has been lowered. So I want to have an equation that shows the total submersion of the cylinder. So the formula is H, which is the submersion, is equal to AB, which is the area of the beaker, times the distance that it's lowered, and that is divided by the difference in the areas between the beaker and cylinder. Okay, and the unit of this is going to be in meters. Okay, so it asks what is the area of the beaker. The area of the beaker is 0.0308 square meters. I'm not going to bother putting those units in because they'll what's in the numerator and the denominator will cancel each other out. The distance is going to be a quantity that that one of our sensors will measure. So I'm going to press on this triangle here and select position. And the AC is the area of the cylinder, which I calculated to be 0.00204 square meters. Okay, and we are done. So everything's been defined in this equation. So I'm going to minimize this calculator window. Okay, next thing, I'm going to select on graphs and digits. Just to make certain that the force sensor is still reading the correct value. I'm going to select force here and hit record. Okay, that is correct, so we can continue on. I'm going to delete these two windows because I don't need them. I just want to see as much of the graph below as I can. And I'm going to maximize this graph to fill up the space available. Okay, the measurement that I'm going to select is force. Measurement I'm going to, and the measurement here is going to be the amount that the cylinder has been submerged. Okay, this data we don't care about, so I'm just going to delete it. At this point, we are ready to do an experimental run. So I hit record. Stop. Okay, so this looks like it's rising, but it's not. The amount that it is getting submerged is increasing. But just to make this a little bit easier, I'm going to switch the signs for the rotary motion sensor. So I can do that by clicking there and changing signs. Okay, so the amount that the cylinder is submerged will now be a positive number. Okay, and I'm going to try this again. And I will hit record. There we have it. Okay, so let's see what the slope of this is. Okay, and I'm going to try to center that. Let me auto scale it. That looks okay. Here's the linear fit. Okay, and so there you have it. There is the slope of the force as it's being submerged into the water. Okay, this is basically the way I gather data for the 3 runs for salt water, alcohol, and water. Okay, and basically that's the experiment. Data will be provided for you, unless you're actually doing this experiment. Okay, well, have a nice day, or good luck on your experiment.